Serverless deployment has a lot of advantages, such as easy auto-scaling, low maintenance, and high availability. So today we will deploy a simple Python application using Lambda, which is a serverless offering from AWS. Our Python application is simple. We will just take file as an input and our Python application will write another file as an output. Serverless functions can be invoked using events. For our application, we will use file upload as an event. When a file is uploaded, the Python application gets invoked. We will upload our file into an S3 bucket, which is a global object store provided by AWS. Once the application is complete, the output file will then also be written into an AWS bucket. The Lambda function is then packaged using Python and Docker, and this whole application then gets deployed to AWS Lambda. Creating a Lambda function has multiple steps in it. The first step is to create our application code in Python. So let's go ahead and create our application code in Python. Here we'll just create an application which counts unique number of words in a given text file. So let's write that logic first. Let's say that it takes file name as an input and returns unique number of words. So we'd have to read the file first. So let's say we read it as different lines. Open the file name with read permission and then read its lines. Then once we have those lines, we can then count how many number of unique words there were. So let's create a set for that, and then let's go over each line one by one. We'd have to convert that into words. So current word in line dot split will give us the words, and then we can add each word into our set as we go along. Once we are done, we can then return the number of words that we have. So a very simple function that takes in a file name as input and then returns the number of unique words there are. Now, main part of the application is to then write a Lambda handler, which will then take care of what happens when the Lambda function is invoked. So let's write that Lambda handler now. Lambda handler takes two things as input: the event which triggered the Lambda handler and the context with which the Lambda handler was invoked. The event variable is like a dictionary. It has various records inside it, and those records are a list. So you have record 1, record 2, and so on and so forth. Now each record will have multiple entries again. So let's say in record 1 you have an entry corresponding to an S3 event that has happened, and within that S3 event you would have the bucket name to which the file was uploaded and the object name, and primarily we'll be concerned with the bucket name and the object name. So those will be the bucket name and the rest of the path for the file that was uploaded. So let's go ahead and get that from the event variable. So let's say our source bucket is event records and then the 0th index, so the first record, and then within that we need the S3 resource, and within that we need the bucket name. All right, then we need the source file. So again, in the event variable, go to records, go to the 0th, go to the first record, go to the S3 resource, go to the object, and then get its key out. All right, now that we have the bucket name and the file name, we can now download the file for processing. So download from S3 using bot03, right? So if you So downloading files from Boto3 is quite simple. First we need to actually import the Boto3 file and Boto3 package. Then we have to connect to the Boto3, connect our Boto3 to the given S3 bucket. So what we need to do is create a session, and that session takes in two things as input. First is the AWS access key ID, and the second thing is the AWS secret key ID, right? And then you can create a session from it, and then from the session you can connect it to a resource. So let's say we are connecting to S3, so you can say session.resource is S3. These two things have to be given, access key and secret key have to be given while creating the Boto session. It is a good practice to then read them as environment variables. So we'd say AWS access key ID can be read from the environment as one of the environment variables. Same with AWS secret key ID, we can read it from the environment variable. We would get to set these two keys separately when we are deploying the Lambda function, so don't worry about that. For now, let's just take both of these things and put them in the correct order. All right, now that we have created a session and then connected to the S3, we can now go ahead and download our file. So I'm going to surround this entire piece of code with a try catch block and do all the processing inside it. Let's catch that exception. All right, let's download the file. So s3.meta.client.download. And for downloading, we need three things. What was the source bucket? What is the source file? And finally, where do we want to download that file to? So let's say we have our source bucket. We need our source file. And then finally, where would we want to download it? So let's download that into a temp folder. And let's keep the file name as the same file, right? Once it is downloaded, you can then give that source file path to our method that we just wrote, count words. So let's say that returns num unique words, and let's count words, and the input path is /temp/source file, right? Once you have that, you can then write the output file now. So let's open a file. Let's open that in the temp folder as well. I'm going to keep the file name as same and just add a .out at the end. So this will be opened with a write permission, and then let's write into it. Let's write something very simple like total number of unique words in the source bucket and source file is num unique words, right? Fairly simple. And this will be written to the output file. After we've written the file, we can close that. Now we need to upload this file into a destination folder. So let's do that. So s3.meta.client.upload file. So for that also we need three things. What is the destination bucket, what is the destination file path, and what is the file path on the local folder, local file system. So first we have to give the path to the local file system, so that we know is source file dot out. Then we need the source bucket. So then we need the destination bucket, and we need the destination. folder, right? And once all of that is complete without any exceptions, you can then print that Lambda execution finished successfully. Otherwise, if you've gotten any exception, you can print that exception out and also print out that Lambda execution failed, right? We do need to declare our destination bucket and destination folder, so let us go ahead and use that also as read that also in from our environment variables. So let's say that this is the destination folder and destination, sorry, that was destination folder, and now the destination bucket. Destination bucket, right? Actually, apart from the folder, you would also need what was the final file name. So we'd have to convert this into an F string as well. And let's write the file name. So that will be source file and then a dot out at the end, right? All right. So that's our entire application file. Now let's go ahead and make a Docker image out of it that we can then deploy as a AWS Lambda function. Now that we have written our application code in Python, we can now go ahead and create a Docker file so that we can containerize that application to deploy. First of all, we need to create a Docker file. So let's go ahead and create that and save that as a Docker file. To create a Docker image, first of all, you need a base image. So the base image that we are going to be using is a public Python image that is available from Amazon. So that is public.ecr.aws, and that's a Lambda image which has Python on it, and the Python version is 3.7. If your application does have any Python requirements, you can put that in a requirements.txt file. So let's go ahead and create a simple requirements.txt file as well. I'm just going to add pandas as a requirement and save that in. In the Docker file, similarly, you go ahead and copy the requirements.txt file into the current directory. Then we have to run our requirement installation. So that is pip3 install requirements.txt. And this is where it gets interesting, because the public AWS ECR images give you some environment variables out of the box. So we're going to use lambda task root as one of the environment variables into which all the requirements and application will be copied over to. We'll copy over our application as well to the same directory, which is lambda task root. And then finally we can just supply the invocation point of our whole application, which is lambda handler. All right, now that we have the Docker file ready, we can now run the Docker commands and then create the image. With our application code and Docker file ready, we can now go ahead and create an image from it and upload it to Amazon's Elastic Container Registry. Our application is ready. Let's go ahead and now create an Elastic Container Registry into which we can upload our Docker image. So on the Amazon homepage, you can search for Elastic Container Registry. Once you're there on the ECR registry page, you can go ahead and create a new repository. I'm just going to call it sample lambda container. We can keep rest of the settings as default. We can enable scan on push so that it's easier for the repository to detect new images as and when we update our images. And now let's click on create repository. Once the repository is created, you can go inside it and view the push commands. Now all we need to do is run the commands in the order that is prescribed. So let's go ahead and run the first one. So right now we just have our Docker file, the application file, and the requirements file. So let's log into the ECR registry that we just created. And as you can see, the login was successful. Now let's go ahead and build the Docker image. All right. So before building the Docker image, we'll have to specify to which platform we are building. So that will be build X build and then a platform name. So for us, it will be a Linux platform. So the name for that is Linux / AMD64. Now let's run this command. It'll take a couple of seconds for this to finish. As you can see, most of the layers were already available, so it took quite a small amount of time to finish. Now let's go ahead and run the next command, which is tagging that container that we just created. All right, once it's tagged, you can then run the final command, which is docker push, and that will push the image that we just created into the ECR registry. All right, the push was finished successfully. Now let's go ahead to the ECR page and see if our image is available there. Let's refresh it, and yeah, our latest image is available over here. We can now use it to create a Lambda function. Now that our image is ready and uploaded into the Elastic Container Registry, we can now go ahead and create a Lambda function. Go ahead and create the Lambda function. So on the home page, let's click on Lambda. So this is our Lambda home page. Let's go ahead and create the function. I'm just going to call it word count sample. We are going to create it from a container image. So we get three options: either author it from scratch, use a blueprint, or a container image. We are going to be using the container image option. Let's call it word count sample. Let's now go ahead and select the image that we want to use. So in the browse, go into browse images. You can see all the repositories that you have in ECR. Sample Lambda container was the one that we had just uploaded our image into. So let's use that. And then let's use the latest image. Go ahead and select that image. Everything else we can leave as default. Let's go ahead and create the function. Alright, once the function is created, what we can do now is do two things. Number one, we have to add a trigger. A trigger would be an S3 bucket into which, when a file is uploaded, the Lambda function would be invoked. So let's go ahead and add that trigger. And the source for our trigger would be S3. So let's go ahead and select that. The bucket that we'd be using here is sample Lambda input. So every time anything is uploaded into sample Lambda input, that file would be picked up as the input for our Lambda function. And let's just say we only want to pick the text files. So the suffix for our Lambda function invocation would be .txt. Let's add that in. Right, let's check this. Let's add that in. All right, our trigger is added. Now let's go ahead and create the environment variables. If we go back to our original application, remember we have 4 environment variables, which are the following. The first one is the AWS access key. The second one is the secret key. Third one is the destination folder. And the final one is the destination bucket. So we need to add all of these in. So let's go ahead and start with AWS access key. So let's click on edit, add an environment variable. So the key would be AWS access key. Let's add one more. That's our secret key. Let's add one more. That's our destination folder. And finally the destination bucket. So let's say we want to upload it into sample lambda output, and similarly we can supply the keys in as well. I'm just going to copy over my keys. So these are the keys. And let's say the folder that we want to upload it to is called output. Let's save all of those things. Alright, let's call it new. Alright, now that we have all of the variables set, we can now go ahead and invoke our lambda function and see its output. Now that our lambda function is ready, let's test it out by uploading a sample file to S3. The lambda function will then write the output file back to an S3 bucket as well. We upload something into this sample lambda input bucket, and the output for that invocation lands in the sample lambda output bucket. So now let's go ahead and upload a file. Let's go ahead and browse and upload a file. I'm just going to use this sample.txt file, which has a few lines of text. Let's see how that gets processed. Let's click on upload. Alright, so sample.txt file is uploaded. In the background, lambda function would have been invoked. Let's go over to the sample lambda output. Let's refresh and see if our output has landed. And yeah, the output sample.txt.out file is there. Let's go ahead and download and see what the final output is. Let's double click on that. Let's open that in Sublime. Yeah, so the output, as expected, it just gives us the total number of unique words in the file that we have uploaded, and it was 14. So our invocation was successful. A few more things we can check out is what were the logs when the invocation happened. So you can go to the monitor tab on the lambda function that you created. You can check out various metrics as to what was the invocation count, what is the duration, what is the success rate, and so on. If you click on logs, you can view the latest log as well. And within the logs, you can see that the lambda execution was finished successfully as we had printed out in our application itself. Hope you guys found this tutorial useful. If you need access to any of the resources used in it, you can go to this GitHub page and access it.